Next award is for institutional building. The Social Science Building, University of Ottawa. With the following team members, please come to the front. University of Ottawa, Diamond Schmidt Architects, KWC Architects, Halsell Associates, Acon Group, Belay Brothers Construction Limited, and St. Mary's CBM. The new Social Science Building and renovated Vanier Hall at the University of Ottawa is a robust structure designed to engage and withstand a large student body and faculty. The 15-story tower and adjacent podiums house 9 departments, 250 full-time staff, and 10,000 students. In order to meet the demands of this activity, the materials selected for the interior public spaces are hard-wearing and durable. Exposed concrete and steel, porcelain tile floors, and glass guards. The Social Science Building has been designed with the intent of producing a landmark building, benefiting its prominent location and its significance for the university. The unique massing and form of the building demonstrates a response to the constraints of building on a dense urban site, and how concrete was used to meet these challenges. Detailing and the use of high-quality, innovative materials and systems further contributed to a distinct building that sets a high standard for future development in this area. Would a speaker please come forward?
Hi, my name is Sarah Lowe. I'm representing Diamond Schmidt Architects tonight, and on behalf of Diamond Schmidt and the whole project team, I'd like to thank the Ontario Concrete Awards for selecting the Social Sciences Building at the University of Ottawa for this award. We're very honored to receive it. I would also like to thank our client, the University of Ottawa, represented by Claudio Brun-Del-Rey, who unfortunately isn't able to be here tonight, and all the project team members, including those that have been mentioned in the introduction, our JV architects in Ottawa, KWC, and especially Dan Carson from Halsell Associates, the structural engineers, who's here tonight, and Michael Cruz from Acon Construction, formerly from Acon Construction, who's also here tonight, and the team from Diamond Schmidt Architects, Michael Lukasik, also an associate at DSAI, who were critical in contributing to the successful use of concrete in this project. Additional team members that I'd like to thank who were not part of the lead construction team include Goodkey Weedmark, mechanical and electrical engineers, and Morrison Hirschfield, the lead and envelope consultants. The Social Sciences Building is unique on the University of Ottawa campus and represents a new direction that the university's strategic planning as an urban university located on a dense downtown site. The essential strategy that is being used in order to make use of expensive property in a dense environment is essentially to build up around the perimeter of the campus, but to retain a pedestrian scale within the campus itself. There were many challenges to achieve this. The building is on a very, very tight, triangular, narrow site, and concrete was a big part of the effective use of concrete, helped to turn many of the constraints that we faced into important opportunities. The main challenge was how to fit a large program onto a small, narrow, triangular site. and connect to an existing adjacent building. Going up, obviously, was the main strategy, but also using every square meter of the site. A stepped massing scheme was developed to effectively distribute the required program on the tight site and relate to varied context around the perimeter in this dense environment. At the heart of the building is a 15-story tower, and it's flanked by 7- and 10-story podiums at the west side facing Nicholas Street and the Rideau Canal, and by a six-story pavilion at the northeast corner of the site addressing the pedestrian campus. So it was important to step down from the tower at the center to address the conditions on all sides of the building. The main structural system is a conventional cast-in-place concrete flat slab system. This choice enabled the design team to minimize the depth of the structure and therefore the overall height of the building in a sensitive setting. It was also allowed the new building to tie into the floor-to-floor heights of the existing adjacent building and still ensure generous ceiling heights and sufficient ceiling space for services. To fit the narrow triangular site, the 7-story podium has a glazed prow and tapers to a flat iron that announces a new campus strategy from the Rideau Canal. The tapered concrete floor slabs at this end of the building are thickened to allow them to be cantilevered from a single row of asymmetrical columns on the east side, which stop short to allow for curved glass to be uninterrupted. To claim an additional 6,000 square feet of educational and multipurpose space that does not impede on the footprint of a future public plaza at the center of the campus, the 6-story northeast pavilion cantilevers out 12 meters. Designing the cantilevered structure to support a 225-seat theater, a large double-height multi-use reception hall, and a green roof required a carefully considered approach. To create the 12-meter cantilever, the innovative solution was to construct story-deep steel trusses to ring the perimeter of the lecture theater, with the bottom cord tapered up from the theater's tiered seating. To resolve the cantilever forces into the concrete shear walls, the trusses were then anchored into the concrete structure utilizing a hybrid construction. The trusses are connected to a 970 millimeter high I-beam. Protruding out from that beam is a series of 760 millimeter high I-beams that provide the framing for the composite slab floors. Concrete provided an excellent way to anchor the cantilevering steel trusses to a stiff main structure. On the interior, the concrete structure is a highly visible element and critical to creating both a hardwearing space that can withstand the impact of thousands of students and faculty using it every day. It is also key in creating generous, light-filled, multi-level public spaces that students and faculty are drawn to and where they want to spend time. Two connected atrium spaces are the focus of the building interior. The main 5-story atrium connects with the renovated Vanier Hall via multi-level bridges. The atrium brings abundant daylight into the interior spaces. A second atrium at the north end contains a vertically planted living biofilter wall at its center. This 6-story green feature is connected into the mechanical system and serves to purify return air as well as contribute to the sense of an outdoor public space running through the center of the building. A 6-story concrete shear wall also functions as the support and frame for the living wall. Precast structural architectural concrete is used to create the atrium's dramatic feature stairs, which span across the atrium space, and 60-meter PA architectural exposed cast-in-place concrete columns are featured in both atriums connecting all levels. The project is uniquely situated at the edge of the campus facing the City of Ottawa, and more specifically the Rideau Canal and Parliament buildings beyond. However, directly adjacent to the site is a busy and noisy transitway. Precast concrete was used as a durable cladding material on the west elevation facing the city. The cladding also represents the concrete structure of the building. In addition, the precast concrete panels were used in a C-shaped profile to create a continuous projecting sunshade above the glazed strips for these southwest elevations, and also support vertical aluminum fins spanning between the top and bottom, which provide additional shading for low sun angles. Concrete plays a multitude of roles in the project, but most importantly, it contributes to a prominent new building at the University of Ottawa, which hopefully represents the future of campus development in that location. And just a few sort of just in conversation before the event started, it was John from St. Mary's CBM noted that there were 58 different concrete mixes on the project, which is quite significant. Significant high SEM in the concrete contributed to 59% recycled material, which helped to achieve a LEED Gold certification for the building. Thank you very much.